Before we begin our study of one-to-one functions and inverse functions in this section, we're first going to review how we determine whether a relation is a function. So hopefully we remember this from a previous algebra course. So example 1a, we're given a set of ordered pairs. Remember, to determine whether a relation is a function when you're given the ordered pairs is to check the x values and see if any of them are the same. So if any of the x's are repeated in two or more ordered pairs, it's not a function. So in this case, that 9 repeats, so this is not a function. So no, it's not a function because that x value repeats. Another way of saying that is, for a given x value, there's more than one y value. So for a given x, we have more than one y. Okay, part B. We're given an equation, y equals x squared. So we know this is one of our parent functions. We're very familiar with this shape. We know it's a parabola opening up with its vertex at the origin. So remember, if you have the graph of a relation, you can determine whether it's a function using the vertical line test. So if we sketch a vertical line anywhere on this graph, it's only going to hit that graph exactly once. It won't hit twice. So that means this is a function. So we say yes, because it passes the vertical line test. Okay, in part C, we're just given a graph, which we can see in this case is actually a parabola opening to the right. So if we use our vertical line test here, we can see we're going to hit this graph twice. So we know that this is not a function, so no, because it fails the vertical line test. Part D, this relation is given in the form of a mapping. So remember, with a mapping, you have your inputs on the left, and then your arrows going to the corresponding outputs on the right. So typically we represent inputs with x and outputs with y. So if we look at our inputs, these are states and the outputs are populations. So we know each state can only have exactly one population. So there's exactly one arrow going from each state to exactly one population. So since there's not multiple arrows coming from any given input, we know that this is a function. So yes, it's a function, and that's because for each input, we have exactly one output. So this is what we said in part A, except instead of mentioning inputs and outputs, we said x's and y's. So for a given x here, we had more than one y value, so that meant this is not a function. So here, for each input, which typically we represent with x, but here it's just the inputs, it's the states, there's exactly one output, so that means yes, it's a function. Okay, now, in part D, because of these arrows going from exactly one state to exactly one population, there's one arrow going to each. That means this is a one-to-one function because there's a one-to-one correspondence between the inputs and the outputs. Because this is a one-to-one function. Okay, so to determine whether a function is one-to-one from its graph, we're going to use, similar to the idea of the vertical line test, we're going to use the horizontal line test. So for instance, in part B, if I draw a horizontal line on this parabola, so for instance, we know 2 key points on the graph of a y equals x squared graph would be 1, 1 and negative 1, 1. So if we draw this horizontal line across, it's going to hit this graph twice, which means for the same output, we have multiple inputs. So in this case, the y value repeats. So when we're determining whether a function is a one-to-one function, you're checking if the y value repeats. So this is not one-to-one. It is a function because it passed the vertical line test, but it's not one-to-one because we have 2 inputs for 1 output. In other words, the y value is repeated. So from the graph of a function, we can quickly check if it's 1-to-1 using the horizontal line test. So everything you know about determining whether a relation is a function, we have a parallel idea, a corresponding idea when we determine whether a function is 1-to-1. So I have a table that organizes this to help you remember. So in the second column here actually, we have to determine whether it's a function, and in this third column here we have determining whether it's a 1-to-1 function. So if we go across here on the left, if it's a function, we know there are no repeated x values. Well, if it's a 1-to-1 function, there's no repeated y values. We know if we're determining if we have a function, for every x value, there's exactly 1 y value. If we want to determine whether a function is a 1-to-1 function, we're checking the other way, and we're saying for every y value, there's exactly 1 x value. And then if we're given a graph, to determine whether it's a function, it must pass the vertical line test. And to determine whether a function is a 1-to-1 function, we use the horizontal line test.